In this tutorial, we'll learn how to use the Identified Text Language plugin for the Butter text analysis software. What this plugin will do is try to algorithmically determine the language that a text comes from, or the language that a text is in. And it does this using a couple of different methods. This is really helpful for cases where we have a really large data set and we want to go through and try to filter out texts that aren't in our desired language. So for example, if we inherited a data set of social media posts or blog posts or something like that, we want to make sure that we separate out anything that is not in English or not in German, for example, so that we can have a nice clean data set to analyze with some other method. Then this is really helpful for that. Now this is built around the mtextcat package, and you can go and see more information on this package and some of the models itself, and we won't get too far into that or the specifics of how this works here. We'll just show you how to use it and interpret the output. Now for this example, I've built a small data set of TED Talk transcripts, and these come from 4 different languages. So these first 25 transcripts I have basically everything beginning with A, or a number here. These are transcripts in the German language. The next 25, everything that's B, are transcripts in the English language. And then we have transcripts in Turkish, and then transcripts in Chinese as well. I think that these are traditional Chinese, but they might be simplified Chinese. I'm not an expert, so I actually don't know. And so what we'll do is we'll let the system go through each of the texts, and we'll see if it can actually correctly identify which texts are in which language. So let's start out by loading up our texts. And we'll point this towards our folder with our texts in it. And we can see that this takes strings as its input type, this Identify Text Language plugin, which is good because most of our input plugins give off strings as their output type. So we can just connect this right to the input node. And if we go to the settings, we can see that there are actually 3 different models that we can choose from to try to classify our texts. Now in my experience, this middle model, the one with 82 languages, seems to perform the best. I find that when I use the model that has many, many more languages, it seems to be somewhat less accurate. And in cases where we're looking just at 14 languages, often I find that this is a little too narrow, and that not only is it not super accurate for the types of data that I work with, but often it'll classify things incorrectly in ways that are problematic for me. Now that said, that could just be an artifact of the types of data that I typically work with, so you may have better luck with one of these other models than what I typically have. And finally, we'll save our outputs. I'm just going to save this to Butter output lang. And let's go ahead and run this. For the most part, it moves pretty quickly. It's not lightning fast, but given everything that's doing under the hood, it's usually pretty sufficient for our needs. Now if we look at the output, let's go ahead and start off by sorting by file name, just so it's easier to see what we're working with here. What we can see is that it seems to have done a pretty good job. These first 25 texts, because this top row is the header, the first 25 texts, it correctly identified them all as being in the German language. The next 25, English, Turkish, and Chinese. So it did pretty good. Now you can see a couple of things here. One is that you get some of these lines that it did not choose a language for. This can happen in a few different cases. In one case, if it simply cannot determine, or if it's essentially a split between multiple languages, then we won't get any output here. The other case is when there is no text within the text file, then it'll also just leave it blank. Now we can also see that there are two columns here. We have language naive Bayes and language ranked choice. And in this data set, they always match up. But these are two different ways that the system tries to identify the text language. And in some cases, you might find that these consistently don't match up. Now for me, I usually have really good luck just using the ranked choice algorithm, but your mileage may vary here, and it may be the case that the type of data you work with, the naive Bayes model performs better, or it could be the case that you may just want to omit any text where there is no agreement here. And generally I find that I get worse agreement when the texts are shorter and shorter. So for example, if you're working with data from the Twitter API, Twitter actually includes a language tag in their JSON data that you get from their API. And often you probably just want to use their model and what their system has concluded before you try running it through something like this. But if you were to work with Twitter data, you'd probably want to aggregate multiple tweets to improve its accuracy. And that's it. That's how we use the Identify Language plugin for Butter.